Panspermia has its roots in Greek. This word means seeds everywhere. The panspermia theory proposes that the seeds of life exist all over the universe and can be propagated through space, from one star system to another. Some believe that life on Earth may have originated through these seeds. How life originated on Earth is a question that people have meditated upon for as long as we can remember. Where did we come from? How did we get here? What are the origins of the human species? What is the origin of life? These questions have plagued mankind's consciousness for eternity. There are numerous theories, ranging from religious doctrine to scientific theories to those on the fringes of science fiction. A possibility that hovers on the horizon is the panspermia theory, which proposes that life on Earth did not actually originate on our planet but was transported here from elsewhere in the universe. This idea seems straight out of a science fiction novel. However, there is some evidence suggesting that life may have its origins in extraterrestrial beings. The Earth was heavily bombarded during a period between 4.0 and 3.8 billion years ago. Researchers believe the Earth endured a very powerful and long series of meteor showers. Evidence for the earliest forms of life on Earth shows their presence around 3.8 billion years ago as well, which makes it reasonable to postulate that all life would have faced extinction during this heavy bombardment period. Life on Earth can withstand extreme conditions. Microbes have been known to survive temperatures as low as -18 degrees Celsius. Bacteria have grown at a temperature as high as 113 degrees Celsius. In fact, many can be frozen in liquid nitrogen for preservation. Some life is able to tolerate high doses of UV and ionizing radiation, extreme pressure, abrupt and radical temperature shifts, etc. These observations suggest that life's preferred and favorable conditions for thriving are difficult to define and predict. Life does not seem to be unique to Earth, as it has been found on meteorites that land on the planet. The presence of water elsewhere in the universe reinforces this. Mars is believed to have contained water in the past. Much excitement for the presence of life on Europa, one of Jupiter's moons, has been fueled by speculations that it may have underground oceans. Water is essential for life. It is the most common molecule in the universe, as it is formed of the two most common elements in it, hydrogen and oxygen. However, while water is essential for life as we know it, its presence does not necessarily indicate the presence of life. Organic matter is common in space. This fact could also support the idea of extraterrestrial life. Organic matter refers to matter composed of compounds that contain hydrogen, oxygen, and carbon. All living things on Earth are carbon-based. An assortment of organic compounds has been discovered in meteorites that have landed on Earth, including amino acids, which are the building blocks of proteins, and proteins are the primary components of all of the living cellular machinery. The presence of carbon-based matter in meteorites supports the possibility that life on our planet could have come from the depths of space. But even though life on Earth is composed of organic matter itself is not considered life. Organic matter arrives from other plants and could have taken shape here. Panspermia propagation methods include the diversion of interstellar dust by solar radiation, gravitational pressure, and extremophile microorganisms jazzing around through interstellar space. In 1743, the French nobleman, diplomat, and natural historian Benoit de Maillet postulated and believed that life on Earth was seeded by organisms from space falling into our blue oceans, rather than life arising through abiogenesis. The theory of panspermia appeared in the works of 19th-century scientists Jöns Jacob Berzelius, Lord Kelvin, and Hermann von Helmholtz. We must regard it as probable in the highest degree that there are countless seed-bearing meteoric stones moving about through space. If no life existed on this planet at the time, one such stone falling upon it could, through what we call natural causes, cover it with vegetation. Lord Kelvin declared it in 1871. Professor Francis Crick, winner of the Nobel Prize and a British molecular biologist, physicist, and neuroscientist, along with British chemist Leslie Orgel, proposed the theory of directed panspermia. In a paper entitled Lithopanspermia in Star-Forming Clusters, published April 29, 2005, cosmologists Fred C. Adams of the University of Michigan Center for Theoretical Physics and David Spergel of the Department of Astrophysical Sciences at Princeton University proposed the lithopanspermia hypothesis in star-forming groups and clusters, in which the chances of biological material propagating from one star system to another are greatly enhanced due to their close proximity. Terrestrial planets are often blasted by asteroids and comets large enough to hurl a rock at speeds exceeding escape velocities. Minerals and rocks can shield microbes from shock and radiation associated with impact craters, as well as hard radiation from the sun as stony meteors move through space. The strongest forms of life seem to have the ability to survive in a cold vacuum by going into stasis, a reduction of chemical activity and metabolism to zero, while maintaining biological structure well enough to later unfreeze and multiply in more salubrious environments. Hypothesizing that life can be seeded into one solar system in a young cluster, either by direct biogenesis or through an encounter with bio-invested material from outside the genesis aggregate. Subsequent dynamical interactions among the constituent solar systems can then allow life to spread throughout the birth cluster. Adams and Spergel conclude that young star clusters provide an efficient means of transferring rocky material from solar system to solar system. If any system in the birth aggregate supports life, then many other systems in the cluster can capture life-bearing rocks. Three popular variations of the panspermia hypothesis are: lithopanspermia. Impact-expelled rocks from a planet's surface serve as transfer vehicles for spreading biological material from one solar system to another. Ballistic panspermia. Impact-expelled rocks from a planet's surface serve as transfer vehicles for spreading biological material from one planet to another within the same solar system. Directed panspermia is either the intentional spreading of the seeds of life to other planets by an advanced extraterrestrial civilization, or the intentional spreading of the seeds of life from Earth to other planets by humans. While the concept of lithopanspermia, in which impact-expelled rocks from a planet's surface serve as transfer vehicles for spreading biological material from one solar system to another, has existed for centuries, the ideas of ballistic panspermia and directed panspermia also exist. To stay up to date with our latest videos and to unravel the amazing things about our universe, make sure to subscribe to the Victory Path YouTube channel by clicking the subscribe button below the video.